Good morning. I am KUSHAL Singh from RCIT Jaipur Mechanical Engineering Department. My today topic is Introduction of Theory of Machine. My subject in fourth semester. Now we will try to explain with the help of slides here. A PPT. The subject theory of machine may be defined as that branch of engineering, science, which deals with the study of relative motion between the various parts of machines and forces which act on them. The knowledge of this subject is very essential for an engineer in designing the various parts of a machine. Subdivision of theory of machines. There are types of theory of machines. There are following types of theory of machine. For example, kinematics. The kinematics is that branch of theory of machines which deals with the relative motion between the various parts of machines without forces applying to it. And dynamics. Dynamics is the branch of the theory of machine which deals with the forces and their effects while acting upon the machine parts in motion. Next is the kinetics. It is the branch of theory of machines which deals with the inertia forces which arise from the combined effect of the mass and motion of the machine parts. It means in the kinematics there is no any type of force considered, but in the kinetics the inertia force is considered generated due to the combined effect of the mass and motion of the machine parts. And the statics, it is that branch of theory of machine which deals with the forces and their effect while the machine parts are at rest. It means there is no any types of motion in the machine parts. The mass of the part is assumed to be negligible. Next is the kinematics of machines. The dynamic analysis of a machine requires the determination of the movement or kinematics of its component parts, known as kinematic analysis. The assumptions that the system is an assembly of rigid components allows rotational and translational movement to be modeled mathematically as Euclidean or rigid transformation. This allows the position, velocity and acceleration of all points in a component to be determined from these properties for a reference point and the angular position, angular velocity and angular acceleration of the components. Now, what is the machine? A machine is a tool containing one or more parts that uses energy to perform an intended action. Machines are usually powered by mechanical, chemical, thermal or electrical means and are often motorized. This is the example of machines which is used to perform tasks with the help of external force that by means of a chemical energy transformed into the mechanical energy. Machines are assembled from standardized type of components. These elements consist of mechanisms that control movement in various ways such as gear trains, Transistor switches, belt or chain drives, linkage, cam and follower systems, brakes and clutches, and structural components such as frame, members, and fasteners. Now, mechanism. A assembly within a machine that control movement are often called mechanism. Mechanisms are generally classified as gears and gear trains, cam and follower mechanism, and linkage through there, though there are other special mechanisms such as clamping, linkage, indexing mechanisms, and friction devices such as brakes and clutches. Now, the next point is structures. If one of the link of a redundant chain is fixed, it is known as structure or locked system. The degree of freedom of a structure is zero. It is important from subject point of view or from competition exam point of view that the question may be put as the degree of freedom of structure is as we remember to as zero. A structure with a negative degree of freedom is known as superstructure. Now, we have to remember that negative degree of freedom is known as superstructure and 0 degree of freedom is a structure. Now, mobility of mechanism. The configuration of a system of rigid link connected by ideal joints is defined by a set of configuration parameters such as the angles around a revolute joint and the slides along prismatic joints measured between adjacent links. The geometric constraints of the linkage allow calculation of all the configuration parameters in terms of a minimum set, which are the input parameters. The number of input parameters is called the mobility or degree of freedom of the linkage system. There are two important special cases. First is a simple open chain and a simple closed chain. A simple open chain consists of n moving links connected end to end by j joints with one end connected to a ground link. Thus, in this case, capital N is equal to j plus 1 and the mobility of the chain is given by capital M is equal to summation of Fi from I to I is equal to 1 to j. Kinematic link. Each part of a machine that undergoes relative motion with respect to some other parts is called kinematic link or kinematic element. Kinematic link help in transmission of motion from one machine part to another. The connecting rods shown in the image below in the brown color are individual kinematic link. They are used for transmitting motion from piston to the crankshaft in an engine. Types of kinematics links. Based on rigidity, kinematics links can be broadly classified into three types as rigid link, flexible, and fluid links. Rigid links. Rigid links are those kinematic links that do not undergo any change of shape when transmitting motion. In reality, no rigid link exists because some changes will be occur during the motion. So there is no any types of links that have no changes during the motion. However, kinematic link whose deformation is very small are considered as a rigid link. Some good example of rigid links are crankshaft, connecting rods, and cam followers. This flexible link. A flexible link is a resistant kinematic link that undergoes partial deformation when transmitting motion. Its deformation does not hinder its effectiveness of transmission. Some examples of flexible links are belt chains. These are the example of flexible links. And next is the fluid links. A fluid links makes use of a fluid, a liquid or gas to transmit motion by means of pressure. Fluid links always undergo deformation when transmitting motion. Some good examples where fluid links are used for pneumatic punching presses, hydraulic jacks, and hydraulic brakes. The example of the fluid links is shown in the following figure. For example, a hydraulic jack, hydraulic press, and a hydraulic jack is shown in the figure that can be up and down the load with the help of compressed the fluid. Thank you.